Hello everyone, very good morning and welcome to the next session of data transfer between multiple programs in the same session or different session. Under this session, we are going to learn how we can transfer the data between two programs using the shared memory object concept, which is the recommended way by SAP to transfer the data within the programs, even two different sessions. So let us see how we are going to do. First, we will see why we are supposed to use the shared memory object concept, because of the reason that it's going to be effective from the performance point of view. That means it's going to give you the good performance. Second important point, that you can check and see what are the latest data captured by the memory, using the transaction SHMM. I'm going to show you that one. Okay. Another important point over here, you can see that it can be used to transfer the data between different above session as well, right? This is third important point. And the fourth one, this is the SAP recommended approach because of these three points. T code which we are going to use is the SHMA. This T code is used to create the shared memory area. Okay, so here the steps I have written. First, you will have to create a root class. In the root class, you will have to define the variable which will be responsible for holding the data content and transferring from one program to another program. Okay, so whatever the attributes in the class you are going to define, with the help of that we can transfer the data. In fact, that attributes are going to hold the value. This is the important interface while creating the root class we have to use. Okay, so the first step, you will have to create the root class. In the root class, you have to use this interface. Then you have to go to the transaction SHMA in order to create the shared memory area. Okay, and in that you have some settings. Just you have to keep the default setting. I will let you know some extra settings over there that just you choose as it is, and it will be good to go ahead. Let's directly jump into the system and come over here. So go to AC24. I'm already over here, AC24. Already I have created the root class. Okay, so this is the root class which I have created. I will explain what we have done extra while creating the root class. Click on this display button, go under the property, and here you can see that this checkbox we have to mark it. So when you are creating the root class, make sure that shared memory enabled checkbox should be ticked. You have to tick it off. Okay, under the interface you have to mention the interface name which I have just shown you over here. This interface we have to mention, right? So just mention this interface. Under the attribute, you have to define the attribute which will be holding the data and transferring from one session to another session, right? So this is the third point. So one kind of data I have used one internal table which will hold the records, and this is simple variable which is going to hold the value and we will transfer from one program to another program. So this one here you can see Z, this is the type, basically table type. Double click, and here these are the three fields we are interested to transfer from one program to another program. And the second one here, int one, you can see, right, of type int one. And this is the method. Okay, so under this method, automatically this build method is Coming over here, we will be writing the code inside this. But before writing the code, what we are supposed to do, that we have to go to the transaction SHMA. We'll have to create the shared memory area. Already I have created this one. Let me explain this. So under this, you have some important parameter, a root class. So under the root class, just the class which I have shown you, you have to mention the root class name over here. So here you can see that this is the root class name, right? This root class you have to copy from here, and you have to simply paste it over here. Okay. Under the constructor class also we can mention the same root class. All right. Then enable this auto area build, and then you enable over here with versioning. Okay. And here you can auto start if read request, and for every validation, you'll have to select this one. Just these are the settings you have to choose. Once it is done, click on this save button. Okay. So okay. So once you save it, automatically it will create a class with the shared memory area name. So just copy this one and go to SC24, and there you can check it out /o SC24, and give that shared memory area name. Here you can see that area I have written, right? Click on this display, and here we have the shared memory area, and here you have the different methods. In this method, we have some important method. Okay. So the very first important method is attach for write. This will create the lock on the memory where you are going to write the content. So very important. Then if you want to overwrite, if you want to reuse that memory area, we are going to use attach for update, as its name suggests, right? And if you want to read the content in the next program, in the second program, then attach for read method we are going to use. Okay. And detach area, just to release the lock. Okay. So attach for write, it will be used to lock the area, and this is to release the area. Okay. So this class also we will be using in the program. Okay. Now let's go back to that root class, and I have already told you that we are going to define the build method, right? So let's go to that class. Uh, we have that class over here. Sorry, here, right? This is the root class. Under the root class, we have to define this method. So already I've written the code. Let me show you what code we have written. And this build method is important. Okay, why this is important? Because this is the method which will be responsible for creating the memory. Okay, so when you are going to call this build method, how we are going to write the code over here, right? We are creating the reference over here. Just see a reference area with respect to the area class which we have created. Just I have shown you the reference root object we have created with reference to the root class, right? And here one exception we have created, right? Just to capture the exception. Okay, we can use the new syntax, and maybe you can avoid this one, but let it be like this, and this is not required. Other thing, let me comment that is not required. Okay, so what basically we want to do, we want to initialize the area. We want to lock the memory area so that we can reuse that memory area for our data transfer purpose. So this is the area class. In this attach for write is the method which is going to lock the area. Okay, and once it is going to lock, it will return the object, and we are capturing that object over here. In case of any discrepancy, any issue, any exception, we are using this catch, right? Then once this area object is generated, you know, what we are going to create the object lr underscore root and the handle, you know, so this root object is going to get handled, you know, with this lr underscore area. And in this lr underscore area, we are going to use this method set root. Okay, and this lr underscore root, which we have a reference over here, right? You know, this object we are going to associate with this area. Okay, so now if you are going to put some, you know, uh, if you are going to put some value in the root class for the attribute, you know, that will be situated in this connected area. Okay, and that's how the data will be stored in this area, and it will be you know, uh, persist over there, and we can use in another program. Okay, and then we can use this method to, you know, for the purpose of detached commit. So this is the method to so here you can see that uh, we have attached to write, means we have enforced the lock, and here we are releasing the lock. Okay, so just activate this one, got activated. Now let's go and quickly write one program. Okay, so this part you have already understood. Now let's go and create one program, and from that program I will show you how it's going to work. Go to SE38, Z SHMM shared memory area report. This is, with the help of this, we are going to export the data from this program. Okay, so export the data from this, export the data simply, and executable program, click on this save button, just save it. And now what we'll have to do, that we have to, you know, we can use directly the new syntax data elo underscore area equal to ZCL SHMA underscore demo underscore IC underscore area. So this is the class which we have created for the shared memory area, right? And under this, we have the method attach for so and we have to first, you know, we have to first build the memory, right? We will have to first build the memory. So let me do one thing, comment this one. First step is that build the memory, then only we can transfer the data, right? Build the memory. So to build the memory, what we'll have to do, that ZCL SHMA demo underscore IC underscore area, and this is having a method called build. Okay, so with the help of this build method, we are going to build the memory area. Okay, so I will show you in debugging how it's going to get work. Basically, you know, it will call, in fact, this root class interface build. Okay, so root class interface build, if you go and check it out, you know, see here, this build, whatever the code just I have explained, this will be getting called. Okay, so it will be creating the area. So we are going to create the area. You can also, you know, do one thing. See, there are multiple exception actually which need to be taken care over here. See, all these exception, you can say automatically it's coming. So we can enable this exception and put inside the try, and catch already there and try. Okay, and after each catch, maybe you can write the return statement if you don't want to go ahead. So double it's coming, let me remove this, right? So, and by default the instance name is going to be the default instance. Okay, so let it be like that, the default instance. Save this one and activate this. Fine, but yet the code is not completed. We have created the memory area, right? Now in the second part, what we'll have to do that we have to get the instance of that area. So let's use the inline declaration and get serial SHMA underscore demo underscore IC underscore area, and this is, you know, the area which we are going to get for the purpose of update. Okay, so attach for update we are just going to use, and again we can put this one inside the try and end try. Okay, so and let's enable this one, right? This is fine. Save this one again, two times it's coming. Let's remove this. Okay, we can remove this one. Let me try if it is going to allow multiple time. You can see that multiple time declaration it will not allow, so we'll have to delete this. Check the syntax now, and this is fine, right? So we got the reference of area from this area class, and once we got this reference, what we are going to do that, you know, uh, we are going to get the root class object. Okay, so already, you know, here what we are calling a build method, and under the build method, if you remember, under the build method, basically what we have written, we have initialized the area, right? Under the build method we have initialized the area. Let me close this. Under the build method we have initialized the area. See here, we are initializing the area, we are locking the area, right? So what it will do that, it will build the area for our purpose, right? Once it is going to build, you know, we are now telling that we are going to update. Okay, once we tell that we are going to update, after that, you know, uh, we are going to update with the help of root class, right? So just get the object of root class, the root class which is already situated in that particular area, right? This LR root, we are going to get this LR root. Okay, this LR root, we are going to get it there. So here LR underscore root equals to here, because we don't know actually, you know, uh, at design time we don't know the uh, type of this LR underscore root, you know, and but at runtime this is going to be like this: LR underscore root type ref2 ZCL underscore uh, root. Okay, so this is at runtime it's going to give it, and this is going to return our root object. So this is going to get our root object. Okay, this also we can put inside the try and catch, try and catch. Catch already there, just simply write and try. So see, so this we are going to get at runtime. At design time, that the value it's going to return, that is not going to be compatible, and that's why we are using this void casting operator. All right. So here you can see that type ref to object. It's the generic, right? Generic object. So that's why we are using this particular operator, so that at design time it will not give any error. If you remove this, the question mark, it will give you the error that not compatible, right? You can see that it's not compatible. That's the purpose. This basic of oops ABAP, I believe you are good in that. Activate this one, and now we got this root class object, and here you can pass the data which you want to transfer. gv underscore value, I want to pass 10 from here, and lr underscore root and another gt underscore it, right? So here also, let's suppose I'm trying to get some data. So select let's see, just go back, go to the attributes, ebln eblp, right? ebln eblp, then aedat from ekpo to itpo. Okay, and some data, all the data it will be taking, that's fine. This is the demo system, there will not be much data, so nothing to worry. And this data it underscore po, we are getting it. Check the syntax, looks fine. And once this is done, again, we have to update the memory, right? L underscore lr underscore root. This we are going to update this data. We are going to update. So lo underscore area, right? lr underscore area. Basically, let me copy this, paste it over here, and in this set root, right? This set root lr underscore root. So just this will update this, okay, the content over there. Check the syntax. Now this is fine, and log we can release now, right? lo underscore lr underscore area and detach area. Okay, sorry, not the detach area, detach commit. Control S, Control F2, and this is fine now. So this is the export program, right? This data we want to get in another program, SC38. Program is the import program. Import the data from export program, right? So one thing over here is the important, like many times you will come across a requirement where in foreground you have to get some maybe purchase order or sales order, and you have to process this purchase order and sales order in the background. So you will be creating a program under the submit using the submit statement, So using the submit statement, you can run a program in the background. Okay, through the job, right? So in such scenario where one program is running in foreground, and that foreground program is responsible for creating a background job, right? And in that background job, you need require to have the data from the foreground program, right? So by this way, like, you are going to have the two ABAP session, right? One is the foreground session and another is the background session, right? So simply you will not be able to send the data. So in those kind of requirement, we can use this concept or cluster data concept as we have discussed in the last video, right? But that concept has been obsolete now. So we are supposed to use this concept. Okay. So this, click on the save button and save this. And how to read the data? It's simple, but you'll have to do that. The beauty of inline data declaration is this one. I don't have to, declare it first. So this is the area class. From the area class, just you get the, a root class to read the data. Attach for read, right? Again, we can enable this and duplicate. Catch statement is coming. Let me remove this duplicate one, or else it will give the error. So just going to remove this one. Okay, put printer, and now this is, let's put under the try and enter, so that in case of any issue, it will give us the idea of what's going wrong. By default, it's going to read the data from the default instance, right? So there also we are putting the data into the default instance. Here also by default, it's going to read the data from the default instance, right? Now from the LR area, which we are getting from there, you just get the LR underscore root equal to LR underscore area, and here get root, right? And this will give you the generic object, right? So what we'll have to do, the question mark, but here we have to define this type ref2 z, that root class, right? So at runtime, it's going to give this a root class basically. And once you got this one, that means you got the data. So try, put the full stop over here, and now in try, and that's it. Now we have to write the data, correct? So one is the CL demo underscore output display data, and LR underscore root, that value. One is the GV underscore value. So GV underscore value, I'm going to display it over here, okay? But I think this should be the string data type. It will give me the error, but let's see. Yes, not type compatible. Yes. So what we'll do that, we will put it, we will make it as a character, data type. So let's make it a character data type. One space, I'll have to give it like this. So now this is your character data type, because I have used the pipe operator. Okay, so it will make it a string, and here that I'm going to display that value, internal table value. So here I'm displaying the internal table value under the value section, and here I'm displaying the value, the single value. So here it should be 10, and here it should be we are going to have that internal table value. So let's go and run that program. Export program This is the export program, right? Put the breakpoint over here and we will see how it's going to work basically. And I will tell you some important point also over here. Very first thing that you will have to build up the memory so that you can put up the data over there in the memory with the help of root class, right? So when you press F5, see here, it's coming right here, and where you are there in the root class, right? So in the root class, you can see that this is the build where we have written the code, correct? So it's initializing the memory and putting the lock over there. Okay, then creating the root class, and area handle is this one, right? So this root class is going to be handled within this area. Okay, now lr underscore area, we are setting the root class lr root within that in that area, and again we are releasing the lock. Okay, then come here. Next, we are getting the area object from the area class, right? Once you got the object, we are getting the root class object so that we can get the attribute and all, and we will be able to put the data, right? We got this object, and at runtime, you can see that this is the value has come. Okay. So LR root G value 10 I am putting. So now the value is set as 10, and this is IT underscore PO 818 records, right? 818 records, all these records are there. 818, remember 818 records. So they should be there in the import program. Okay, so this data also set root, this also, and it has commit, right? So press F8. So from this program, we have set up the data. Now this data which we have set up, we are going to get it where? In the import program. This is what we have, the import program. Okay, save this one, activate this, put the breakpoint. I will show you how its behavior. And let me close some session. So now I switch to the standard debugger, new debugger, and here, see here, and now you will see that, see 818. So in the import program, import report, you have 818 records and the GB value is 10, right? So you are able to get successfully data in the second program, right? So what we did first, we got the instance of the area which was already created, right? Using this method. Once you got, once we got that area object, in that area object, whatever the root class we were having, that we got from that area object, and from that root object, we are able to access the value, right? In the root object, we have defined the one for internal table and another for the global variable, means single value, right? And here you can see that. And now press F8 and you will be able to see that it's displaying the data. See here, the 10, that single value, and here you have this data, right? So 818 records are now displayed. So in debugging also I've shown you that 818 records, it's perfectly getting and fetching, right? So this is how you can use it. Okay, so this is the way we can use the shared memory object. What I will do, that I will put the this code which I have written it over here. All this export and import code I will be putting into this my website. You can go and read out from this blog section. Okay, I will give the link for that. Okay, I will give the link for that in the description section, so we'll be able to get. However, you can get several blogs from there also. You can uh, find it out. Okay, so for this course, for this code, you can get the link in the description box. Okay, so if you found this video useful, just type useful in the comment box, and thank you for watching. Bye bye, take care.